Welcome to this Sahara 4 exercise. In this exercise, we will import petrophysical data to the project. This is information belonging to the layers, but that are defined for the XY position of the well in that layer. For example, the top of the layer, the base, the permeable thickness, the porosity in that position for that combination of well and layer. To do this, we will open Sahara and go to the project we have been working with previously, import petrophysical data, and we are going to select the Excel file we have been working with and go to the Excel sheet petrophysical data. Here, something very important to consider when we are importing this information, petrophysical data in particular, is that we have two different formats in which we can import the information. In the case of this file in particular, we are in the record format, but also is available the table format. In the table format, we import each row is going to belong to a different well. In this case, we have the same well here, but it will be D2, D1, D2, D3, D4, and then more and more wells below. And then each column is going to belong to a different layer. And then in this checkbox here, in this drop-down menu, we're going to define which variable we are importing. So with the table format, we can only import one variable at the time. But if we need to import in the record format, which is the case for this file, we are going to have the combination of this column and this column, ID and layer, is going to define to which combination of layer and well we are talking about. So we are describing how these variables are which variables we have for the combination of D1 and this layer C1. We have the top here, we have for D1 and this layer, we have this top, this gross thickness, this net thickness, and then with only these two columns we are going to describe each combination of layer and well that we have information of. And then we can, in the rest of the columns, describe which petrophysical data we want to import. In this case, we have net thickness, gross thickness, porosity, the top of the layer and the base of the layer, and a qualifier. We need to change the units because the original information for this project was in meters, so we will change the units. Gross thickness, this one doesn't change. This one is going to be meters MD. Measure depth. Yes, this is going to be meters MD, and this is going to be meters measure depth. So here a couple of things to consider. First, in the ID column, we are going to describe or define which well we are associating the information to. Here, when we created these objects, we define names, the code of the well, and the true name. All these three are unique to each well. Name, the code, and the true name are all unique to each well. Not the alias. The alias can be repeated, so only these three could normally be used as identifiers. And when we select the all option here, Sahara is going to try to find any of those three in this column to recognize which well we are talking about, and then import the information there. So normally we will leave this, if these identifiers are correct, we will leave this with the all option that is going to search between the name, the code, and the true name to associate the information of the Excel file with the well in particular. The next point that is important to have in mind is the difference between measure depth, true vertical depth, and true vertical depth sub C. In the case of measure depth, we are going to refer this depth that is going to be measured along the well's trajectory from a point above the sea level that is called the datum. From true vertical depth sub C, our point of reference is going to be negative from the sea level downwards. So in this case, we are going to use a common point that is going to be the zero for all wells. That is the sea level, and this will allow us, for example, to draw a structural map that we wouldn't be able to with measure depth because the datum is going to be different for each well. In general, the measure depth is used for well logs, or is used to describe the interventions of the well, or in this case we are going to use it to describe the position of the top of the layer from the point of view of that well, from the trajectory of that well. TBD subC is more common to use in the structural maps because we need to have a common point of reference that in this case is the sea level. Another unit that is less common is the true vertical depth under sea level, in which case is positive instead of negative. True vertical depth sub sea is referred to the zero is the sea level, and from them downwards we have more and more negative values. So the more negative, the more depth that we have. So we review the rest of the data, we have everything okay, all the units are in order, so we are going to import the file. And as we can see, we have imported all the data that we had, and everything was fine. All this information importation has this report here that if in the case we have any issue with information imported, is going to be indicated with different warnings. Okay, so everything was imported correctly, and that will be all for this tutorial. Thank you for watching.